Okay, so today's opener, the first two are just like what we did last week. You're looking at each square root and you're simplifying. Then the next two are going to be the new lessons, adding and subtracting square roots. So let's take a look at the first two. What do you notice about these two square roots? Yeah, one's a perfect square. Which one's a perfect square?
36.
The square root of 36. So how can I show that it's a perfect square? Go ahead, Darius.
Is it 6 times 6?
Somebody help him out. How do I show that the square root of 36 is a perfect square? How do I show my work for that? Because I can't just write 6.
You draw your factor tree.
No.
So you don't draw.
Wait, hold
And
on.
then cross the 2 out. And then equal 6.
Okay, so that's one way you can show your work. Time out. There's more ways that you can show it though. So you could show that it's a perfect square by just showing the square root 6 squared and show that the square root and the 6, that the square root and the square cancel to equal 6. Or if you didn't know that it was a square root, you could do your factor tree. And if you did your factor tree, you would still end up with the answer 6. So if you chose to do your work the short way or the long way, they're both acceptable forms as long as you showed me all of your work. All right, let's look at the next one here. The next one, we start with the coefficient, 3 square root 50. Jemiah, what are two factors I can use for 50? And for 10? When I go to rewrite this, Jemiah, what do I need to make sure I put first? Very good. So put your 3, your coefficient, square root, and what are your factors? Okay. Then I'm going to circle my factor pairs. Factor pair cancels and joins my other number out in the coefficient. So what's my new coefficient going to be? My coefficient.
3. No.
It's 5.
3 times 5.
Good. 3 times 5. Because I already have one number in the coefficient here. This 5 canceled and is moving to the coefficient. So you're going to have to take 3 times 5 and get 15. Square root, what's stuck in the Radican yet? 2. So that will be your final answer. All right, let's take a look at the next one. Okay, so I'm going to just call on you guys. So I'm going to have Brendan factor all my numbers for me. So go, Brendan. You're going to go through and factor all my numbers for me. So what's 2 factors of 8? Okay, then for 4? I'm sorry, what times what for 2 4s? What times what equals 4?
2.
Now for 28, we're going to use 4 and 7. Bless you. 7 is prime for my 4. Okay, for 63. Look at your sheet. You know. Shh. 21 and 3. Okay. 3 is prime. For 21. And for 50. And for 10. All right, this next part, Nick, nice and loud here. How do I rewrite each of these? Under my square root sign, right? Then what do I bring down? Then what do I bring down? Before that square root, what can I not forget? Don't forget that 5 square root. Then what are your numbers? Okay, then what? Okay. All right. Perfect. Jemiah. Okay, tell me.
2, 3, 5.
Kelsey, now what?
You cross them out, and then you get 2, square root of 2, and then you get 5.
Okay. I cancel out my 2. I move it to the outside. So bring down my subtraction sign. 5 times 2 is 10. Go ahead.
Of 7.
Square.
Yeah.
Okay, bring down my,
Plus 1.
okay.
And then you cancel one of the 3's out. Then you get 3 square root of 7 minus, and then you get 5 square root of 2.
Nice. Okay. From here, I am now going to, I'm going to simplify. I'm going to look at my radicants to find my like terms. I'm going to put them in order from least to greatest. So if I'm going to simplify this in order from least to greatest, which 2 terms am I going to simplify first? Darius? So the 2 square root 2 minus 5 square root 2, okay? So you're going to combine your coefficients here. So what's 2 minus 5? Negative 3 what? Okay, yeah. Yep, because our radicants stay the same. So then what are my second like terms I'm going to combine?
Negative 10, root 7, 3.
Okay, so simplify your coefficients here. So negative 10 plus 3 is?
Negative 7.
Okay.
Square root of 7.
Yeah, perfect. And then box it. That's your final answer. Get it? Good. All right, last one.
I know. Wait, hold on. I did the back and the side.
All right, go.
Oh, 20, put a 420. And then put 4, 5 on the other side. And then after that, you put 4, 2, 2. You circle your, yeah, 2, 2. And then 28, you put 2 times 24. Go to 24, you put 2 and 12. And then after that, 2 and 6. Then after that, 2 and 3. And for the 75, you put 5 and 15. 3 and 5. And then after the 9, put 3 and 30.
Let's got the next one. Nick.
I got a question.
Oh, sure.
29.
That's 24.
Oh, that's a really ugly 24. Yeah, I'm sorry. For 48, it's 2 times 24. If it was 29, what kind of number would that have been? It would have been a prime number, so I couldn't have factored it. Yeah, it's an ugly 24. Sorry. Okay, so now I'm going to drop down. Darius, tell me what's right.
For the first one, you're right. Square root 2 times 2 times 2. 2 times 5 times 5.
Okay.
Then for the next one, you right.
What do I have to bring down?
Subtraction.
Okay.
Then square root. Then 2 times 2 times 2 times 2 times 3.
Is that right?
Yeah.
Okay, then what?
Then you put your plus sign. Then you put 3 times 5 times 5.
And
Then subtraction sign. Then 3 times 3.
before I go any further, can anybody tell me something about some of these square roots here?
There's a lot of pairs
Well, there's a lot of pairs. Why? Why are there so many pairs?
because you're working with numbers. Is that right?
Ain't all these perfect numbers.
Not all of them. Which ones are going to be perfect squares?
That one and No.
The 400 is a perfect square and the 9. Okay, let's circle our pairs. So we have a pair of 2s, 2s, and 5s. So there's our perfect square. 2s, 2s, 5s, and 3s. All right, when I go to rewrite,
The first one.
so the first one, they cancel out the square root. So we're going to take 2 times 2 times 5 and get 20. Minus, okay, a pair of 2s and a pair of 2s both cancel at the square root. Negative 4, good. She's got it now. All right, bring down my plus sign, then what?
The coefficient is 3 with 5.
Coefficient is 5.
Yeah.
Coefficient. All right.
Then you can put your 3 and right click there. Subtract it.
Now it's the tricky part. I need to combine my like terms here, but which one do I do first? Rihanna?
What did you do first is, don't you do the least one?
Mm-hmm. Which?
That's 20 and 3.
Good. Good. So the one with the smallest radicand is going to be 20 minus 3, because basically there's no square root with it, so the radicand's 0. So what's 20 minus 3? Okay. So 20 minus 3 is 17. Then my next like terms is negative 4 square root 3 plus 5 square root 3. So what's negative 4 plus 5?
Is it 1?
1 square root,
3? No.
yeah,
Yeah.
3. Excuse me, how can I write this in simplest form?
17 plus square root 3.
Get rid of the 1, right? So square root 3. You can leave the 1 there, but if you're writing it in simplest form, you can just get rid of it. Either way would be acceptable.